Welcome to the channel. So today's video is about another lead code problem in which we remove the nth node from the end of the list. First of all, we will see the problem, like what's there in the problem, because uh, it is said that half of the answers in the problem, and we have to understand the problem quite well. So they are basically saying that we have been given the head of the linked list, right? So when the head of the linked list is given, we have to remove the nth node from the end of the list. If we have been given this problem right here, then if they are giving us two, then then what we have to do is, this is one, this is two, we have to delete the second last node, right? So we have to basically count from the end. Okay, so let's just see another case. So here you see that there is only one node, and this is one, so it will become only one, and we have to delete that node. If we are given two nodes, and we have been given n equals to 1, it means that we have to delete this 2 right here. Okay, so I guess that the problem is pretty clear, and we will discuss here two approaches, that how we can easily solve this problem. So uh, first of all, we will discuss the problem, like which codes is here. So if we have been given like this linked list, and we have to delete n equals to 2. So what does it means? That we have to delete this 3, right? Okay, so we are using two pointer approach here, fast and slow pointers. So what we will do is, we will declare a fast pointer and a slow pointer who have the address of the heads, right? Who have the same address as the head. Okay, so head is pointing to basically this one, so these two fast and slow are basically pointing to this one, right? Now we have applied a for loop in C++, which is basically, it will move from 1 to n. So in the first go, uh, so in the first iteration, basically our fast will go to here, and here our I becomes 1, and okay, so our in the first iteration, you will say that our fast will move one step, and after that this will, you know this basically has an increment, and it becomes 1. So 1 is less than 2, and the fast will be at there, in onto the next iteration, and here it becomes 2, and 2 is not less than 2, so fast will point to this 3. Okay, so we will skip this fast equals to null ptr, because this is the edge case. We will discuss it in a while. So there is a while loop which basically says that we have to move the fast until its next becomes null, right? This is basically the short form of writing that. If you don't want to write this, you can say that fast next not equals to null ptr, right? Okay, so what we will do now is, our slow is pointing to this, right? We have discussed this, that our slow is pointing to the address which the head holds, right? So fast will move to one step, and fast will go to, slow will go to here. Fast also move one step, and fast will go to here. Okay, so now you see that fast next now is null, right? So basically this while loop doesn't work, and we will go to here, that slows next. This is slow, this is where the slow is, and slows next will have the value of slows next, right? Slows next is basically this, and slows next is basically this. So what our list has become, this is something like this, right? So we have successfully deleted our second node from the end, right? So this is basically the first approach, which is, very simple. So next we will discuss the second approach, right? And that approach is also very easy. Okay, so if we are uh, if we have been given this linked list, right, and our n is basically 2, right, n is 2. I know that I have not discussed this edge case. I will discuss this later on. Okay, so our n is basically 2, right? So first of all, what is the first step is we have to calculate the length of the linked list, right? When we calculate its length, so we will say that its length is 4. Like, you have to maybe write a function, or you can write it here, or you can write it some making it a different function. So first of all, we have to calculate the length, which is basically 4. Next, what you have to do is you have to calculate length minus n. So length is basically the length of the linked list, and n is basically what they have said us to delete, and this will become 2. So 2 is right here, right? Like, we have to delete it from the end, so 2 is right here. Now what we have to do is we have to maybe set a maybe apply a while loop uh, in the first iteration of that while loop. Suppose we have created two variables, right? So we can say that our we have two, one is variables, one is count and next is counter, right? So counter has the value of this two, right, which we have calculated. So in the first iteration, our and we have a pointer called current. So in the first iteration, current is pointing to this, like current will move here, and because we have initially you know give it the value of 1. So in the very first iteration, when we do a increment, it will become 2, and if it becomes 2, then it will not go further here. And what we will do is we will assign its next value to its next value, like we have done this. So this is the second approach, which is I think so very simple, and these two approaches are obviously very simple. So okay, so I think so the two approaches are very simple, and yeah, very less lines of codes are needed. Okay, so this is the edge case which we were talking about. Okay, so if we are given this, and our length is here 3, and they have given us n equals to 3, right? So they are basically, because this is 1, this is 2, this is 3, they are saying that we have to delete this 1. So what we will do is we have declared this. First of all, fast will go to this, then fast will go to this. Obviously I here is 1 and I here is 2, right? Okay, then here is null, and it will fast will go to here. Okay, okay, so fast at this point is basically at null position, right? So if fast is at the null position, we have to we have to um return the heads next. Head is pointing towards the first node, so heads next is basically 2, so we will return this 2. So this whole thing, like 2 3 will go uh, back, right? So what we have done, that we have skipped this thing, but you know that in C++ we have to free the pointers, so you can just uh, hold this address in some pointer, in some dummy pointer, and delete this by using the delete keyword. Okay, but this is basically the edge case which I was talking about. So I hope that you get the solutions, and if you have any queries, you can ask me in the comment section, and thank you so much for watching the video.